We're going to do dimensional analysis part 2 of dimensional analysis. So let me just remind you again that what we're doing is we're multiplying by things that are equal to 1. Okay? So if I had a competition and I said, you can have, I have 2 hands full of money, and you can have the money that's in one of these hands if you pick the hand that has the most money in it. And I'm going to open my hands, I'm even going to show you the money. Okay? And in one hand, I have 5 $1 bills. And in the other hand, I have 1 $5 bill. Which do you pick? They're the same, right? They're both worth $5. One's not more than the other, is it? 5 $1 bills is worth $5. 1 $5 bill is worth $5. So they're worth exactly the same. So I could write $5 times one of them, or $1 times 5, and those are exactly equal. And when you put the same thing on the top and the bottom of a fraction, it equals 1. Let me give you another example. If I said that there was 1 day, or I said that it was going to be 24 hours, that means exactly the same thing. 24 hours means 1 day. So I could say 24 hours over 1 day. That still equals 1, doesn't it? Because 1 day is 24 hours. Or I could do it the other way around. 1 day over 24 hours. And it still equals 1, right? So with dimensional analysis, what you're doing is you're using this kind of information to convert from one unit to the next. So let's do an example. And this one's a little more complicated than the other 3 we've already done. This is number 4. We're going to take 22.4 kilograms per liter, and we're going to convert it to kilograms per milliliter. Well, my kilograms is the same, so I don't have to do anything with that. But I have to go from liters to milliliters. So I'm going to think in my head, what do I know about milliliters and liters? I know there are 1,000 milliliters in 1 liter. Just like I said 24 hours was 1 day, I can say 1,000 milliliters is 1 liter. So here we go. First thing you do is you always write what you know. 22.4 kilograms over 1 liter. Now there's not a number 1 there, but it's invisible. It's there. And sometimes you'll see it written like this, kilograms per liter. Go ahead and straighten that out for yourself. Make sure you make your line is right here. So the 22.4 is in the numerator and the 1 liter is in the denominator. Now, the way I do it is I always have a multiplication sign, and I'm going to multiply by some fraction that's equal to 1. In this case, I have the word liter in the denominator, and I want to get rid of it. Do you remember back when you used to have a problem like 12 over 30, and your teacher would say, simplest terms, you need to reduce that, you need to reduce that, and you'd say, oh, I can take a 2 out of both of them. What you were really saying is 2 times 6 and 2 times 15. 2 over 2 is equal to 1, isn't it? And now you have 6 over 15. And you look at that and you go, oh, I can take a 3 out of each of those. Well, that's 3 times 2. Isn't 6 3 times 2? Yep. And 3 times 5. So now I have a 3 over 3, which is equal to 1. So that's why I can cancel those out, and I end up with 2/5. We're doing the same thing here, only we're using words instead of numbers. So if I have liters in the denominator, to get rid of it, I want liters up here. That's how I'm going to get rid of it. And liters and milliliters are what I have in my conversion factor. So the 1,000 is next to the ml, and the 1 is next to the L. The L's cancel out, and I'm left with kilograms per milliliter. If I make this a straight line, and I go like this, that should look a lot like the ladder that a lot of teachers teach with. Everything above the line is multiplied, everything below the line is divided. So 22.4 times 1, that's 22.4, divided by 1,000, you can just use your calculator and divide that. And what I come up with is 0.0224 kilograms per milliliter. And that's my answer for that problem. Now that changed 2 things. We really didn't, but we had kilograms and liters both. Let's do another one that's a lot more complicated, because I know you're all feeling really brave and you're feeling like you can handle these problems with no problem. So let's do this one. 8.24 grams per square centimeter, and I want to know how many milligrams per square millimeter, that is. So that's another layer of complexity. I'm going to go from grams to milligrams, so I've got to get grams to milligrams. I know 1 gram is 1,000 milligrams. Centimeters to millimeters, same thing. 1 centimeter becomes 10 millimeters. So now I think I have all the information I need. I can start my problem. 8.24 grams. And instead of writing centimeters squared, I'm going to write centimeter, centimeter, because that's what the square means. It means centimeters times centimeters. If it was cubed, I'd say centimeters, 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 but it's squared. Always going to multiply something equivalent to 1. And at this point, it doesn't matter. I can either get rid of the grams or get rid of the centimeters. Let's do the grams first. No reason, let's just do it. Grams is in my numerator, so to get rid of it, it needs to be on the opposite side of the line, it needs to be in the denominator. I'm going to end up with milligrams. I have 1,000 milligrams for every gram, and my grams cancel out. Now I need to get rid of centimeters and convert those to millimeters. So centimeters on the top, because this is on the bottom. This is in the denominator, that should be in the numerator. Millimeters. And if I look at my conversion factor here, the 1 is next to the cm, and the 10 is next to the mm. And I cancel that out, but if you'll notice I have a second cm still here, so I have to do this one more time, get rid of that second centimeter, be left with millimeters. 10 millimeters is 1 centimeter. And now if I look what I have left in the numerator, it's just milligrams, and in the denominator it's millimeters squared. I like to draw my line. Everything on top of the line is multiplied, everything on the bottom of the line is divided. So I take 8.24 times 1,000 times 1 times 1, divided by 1, divided by 10, divided by 10. And when I press the keys on my calculator, I find out that my answer is 82.4 milligrams per millimeter squared. And that's your answer.